All right, guys, in this section 7-5, we begin looking at solving trigonometric equations. And so the first thing that I've given you here is a table with the trig functions and the period, along with the domain and the range for each one of the functions. And so this is going to be important when we're solving the equations to make sure that, number one, the answer that we get falls in the correct domain. Okay. And number two, the equation that we get right before we solve it, when we take it down to where it's just the sine of the x or the cosine of the x, whatever that's equal to falls within the correct range. Because if it doesn't, then you would have to throw that answer out. Okay, and you'll kind of see what I'm talking about as we go through and practice solving some of these equations. All right, so here's the first one that we come to. So we want to solve 2 sine of x minus 1 equals to 0. All right, so with a problem like this, all right, so 2 sine of x minus 1 equals to 0. A lot of the properties that you would typically use to solve an equation are still going to apply here. Like, for example, we want to try to isolate the x, so I'll move the 1 over to the other side and divide by 2. We can do that all in one step. And then we'll get sine of x equals to 1/2. All right. Now, before we proceed, all right, we've got to make sure that the sine of x is equal to something that's within the range. If it's not, we would have to say that this equation has no solution. So the range for sine of x is between -1 and 1, and 0 is between -1 and 1. So we're okay on the range. All right. So now we can proceed to get the solution. Okay, so what are we looking for here? All right, we're looking for angles whose sine is equal to 1/2 within this period, all right, within this 2 pi period. So that 2 pi would be the entire unit circle. So we need to find angles on the unit circle whose sine is 1/2. Well, remember, on the unit circle, the sine would be the y portion, right? So I'm looking for places on the unit circle where the y is equal to 1/2. And so I find one here at pi over 6. So x is equal to pi over 6. All right. Comma. Anywhere else? Looking for y 1/2. Let's see. We've got one here at 5 pi over 6. So that's another answer. 5 pi over 6. Any others? That's -1/2. We don't want that. -1/2. We don't want that. All right. So those are my two answers to this equation. X is equal to pi over 6, and it's equal to 5 pi over 6. Now, I say that those are the two answers. Those are the two answers over the interval of the first period. So over the interval. So these are the answers over the interval from 0 to 2 pi. Over the interval from 0 to 2 pi. All right. And of course, we'll put a closed parentheses right here because 2 pi would be the same solution as the 0. So you don't want that to repeat within that interval. All right. So again, these are the two solutions that are within this interval. So this can be referred to as the interval solution. However, these are not the only solutions to this equation because, remember, the trig functions are periodic in nature. Okay, so every time I go around another 2 pi, then I should be able to pick up another 2 answers. Okay, so really, if you're looking for the solutions over a certain interval from 0 to 2 pi over the first period, these are your answers. But if you're looking for all the solutions, there are more. As a matter of fact, there's infinitely many. So anytime I add a full period to either one of these, that is going to give me another solution to the equation. Okay, so if I really wanted to write out the general solution for all infinitely many answers, you might be asking, well, how can I do that? This is how. I can take the x, and I can go pi over 6. And anytime I add a multiple of 2 pi to this, that's a valid solution. How am I going to express that? As 2 in pi. Okay? So anytime I put in a multiple of 2 pi by plugging in a 1, a 2, a 3, or a 4 for that, for n, then that would come up with another valid solution. Right? Likewise, if I take 5 pi over 6 and add any multiples of 2 pi, 2n pi, that would also be a valid solution. So this would incorporate all infinitely many solutions, and this is referred to as the general solution. All right. So this is the solution over the first period. This is the general solution over all intervals. Okay. So again, this would be the infinitely many solutions. These are the only 2 solutions within the first period. All right. So you could be asked to express the solutions either way over a certain interval. And by the way, that interval doesn't always have to be the same as the period of the function. And you'll see what I mean by that here when I point out some of the other problems that are on your quiz here toward the end of the lesson. Okay, so you could be asked to write the solutions over a certain interval, which may or may not match the period, or you could be asked to write the general solution, in which case you would write this. Okay, or you could be asked to write both. In all the examples that we're going to be doing here, we're going to write both so that you can see how both are written out, so that you can be prepared for whichever one they ask you for. So this is the solution over the interval of the first period from 0 to 2 pi. This is the general solution. This is all solutions have this form. So anytime I plug in an integer value for n, any multiple of 2 pi, 4 pi, 6 pi, 8 pi, and add it to this solution, that will give me another valid solution. All right? Okay, so let's try a few more so that we can get more proficient at it. So here with this particular one, the first thing that I'm going to do, and one strategy when you're solving these equations, is to get all the sine functions together, get all the trig functions together on one side. So I'll move this over and I'll move the square root of 2 to the other side. When I do, it's going to look like this. Sine of x plus sine of x equals to negative square roots of 2. All right? So from here now, I can add those together and get 2 sine of x equals to negative square root of 2. All right, so from here, I'm still trying to isolate the x, so I need to divide both sides by 2, and we'll get sine of x is equal to negative square root of 2 over 2. All right? So now at this point, remember what we've said before, you want to make sure and you double check that whatever the sine of x is equal to is within your range. So negative square root of 2 over 2, if we wanted to quickly divide that out, we could see negative square root of 2 over 2. So that's equal to negative 0.707, which is within the correct range between negative 1 and 1. Okay? And it is important to check that every time once you get to this step, because remember, if this value is not within the range, you stop right there and the answer is no solution. Okay? So be careful with that and make sure that you always check that once you get it down to sine of x equals to something, or whatever the trig value is of x. Once you get it rearranged down to this, check the range and make sure that you're in good shape. Okay, because you will have some equations that have no solution, so you got to check that. Let me see, what else? Okay, so from here, what are we looking for? Now we're looking for angles whose sine is negative square root of 2 over 2 over the 2 pi period. So over the unit circle, we're trying to look for angles that would give us negative square root of 2 over 2. And remember, again, sine is the y value in the ordered pair on the unit circle. So I'm looking for places where the ordered pair is negative, the y value of the ordered pair is negative square root of 2 over 2. Let's see if we can find them. All right, so here's square root of 2 over 2, but I need negative, right? Okay, so there's a negative square root of 2, negative square root of 2 over 2, but it's not the y coordinate, it's the x coordinate, so we're going to keep on going. Okay, so here's a negative square root of 2 over 2 for the x coordinate, and that occurs at the angle of 5 pi over 4. Okay, so 5 pi over 4 is one solution. Okay, and let's see if there's another one. So we're going to continue going down the unit circle, and I've got another y value of negative square root of 2 over 2 right here at 7 pi over 4, and so that's the other solution. And so that's the only 2 over the interval from 0 to 2 pi. So remember, this is my interval solution. My interval solution from 0 to 2 pi. That's the interval solution from 0 to 2 pi. If they asked me for all of the solutions, I would have to write it in the form of the general solution, which is going to be x equals. And remember, to obtain the general solution, you take each one of those specific solutions and add any multiple of pi, which we write in the form of 2n pi. Since the period is 2 pi, we place an n in there to represent any integer we want to put. 1, 2, 3, 4, negative 2, negative 4, negative 6, whatever it is. All right, so that's the first general solution. And the second one likewise, 7 pi over 4 plus 2n pi. And that is the general solution. So that's the general form for all infinitely many solutions that you would have to this equation. All right, so there you go. And like I say, you could be asked either one. You could be asked for a solution over a specific interval, which would be this from 0 to 2 pi. Okay, or you could be asked for the general solution, which we would write in this form. Okay, now, like I said in the last one, the interval that you're asked to write the solutions out for don't have to match the period. A lot of times they do, but they could have asked you for all the solutions over the interval from 0 to 4 pi, in which case we would have to add 2 more answers to that. I would add 2 pi to this and get the third answer, and add 2 pi to this and get the fourth answer if the interval was from 0 to 4 pi. And if it was from 0 to 6 pi, I'd have to add 2 pi 2 more times and get 6 total answers. Does that make sense? Okay. Like I say, I'll point that out when we look at the quiz here in just a moment. All right. Several more examples we want to take a look at here because, like I said, there's several different types of equations that you could be asked to solve. Okay, so here we've got 3 tangent squared of x minus 1 equals to 0. So we're dealing with some trig function squared now. Let's see how we handle it. So first of all, I'll move the 1 over to the other side, and we will get 3 tangent squared x equals 1. All right. So from here now we can divide both sides by 3 and get tangent squared x equals to 1/3. All right, so now the question is, what are we going to do from here? So tangent squared of x equals to 1/3, right? And so remember what this refers to, right? This is tangent of x times the tangent of x, right? So it's happening twice, so it's tangent squared of x. All right? So think back when you were solving any kind of an equation with a squared in it. Well, what's the opposite of squared? Square root. So we're going to take the square root of both sides. Well, the square root of tangent squared is just tangent. So that'll be tangent of x is equal to. Now, the square root of 1/3, remember when you're solving an equation and taking the square root, you generate 2 solutions, a positive and a negative. So that would be positive and negative 1 over the square root of 3, right? Because you're taking the square root of 1/3. All right. Now, from here to kind of put it in a, let's see, we need to rationalize the denominator is what I'm getting at here. So this will be tangent of x is equal to, so when I do that, oops, we're going plus or minus square root of 3 over 3. All right. Now, remember what we said. We always need to double check and make sure we're still within the correct range, right? So let me divide this out and see what that's equal to. So to save a little bit of time, I'll just go 1 divided by square root of 3. Okay, so that's 0.57. Is that within the correct range for tangent? Let's see. So tangent range is all real numbers, so we didn't even really have to check for that. But you always got to double check and make sure that you're not outside of your range. All right, so this one does have a solution. All right, so what are the solutions going to be? The solutions are going to be where the value of the x, right, can give me either, okay, the tangent of the angle gives me either square root of 3 over 3 or negative square root of 3 over 3. Either one of those can work, all right? And so one thing that we can kind of look at here is when we're trying to figure out where those occur on the unit circle is we can start, and remember tangent is y over x. Tangent is y over x. So I need my y divided by my x to be either a positive or a negative square root of 3 over 3. Okay, so as we go through and look at these, let's just go through and see if we can start here and pick something up. All right, so here I've got y over x, which when I flip this, the 2's will cancel out, and that would be 1 over square root of 3, which is indeed what I'm looking for. So that's actually one of my solutions, pi over 6. So x is equal to pi over 6. All right, so let's see if there are any more. Now, here's another thing that we need to, let me see, do I need to point that out here at this point? Yes. Okay, so the period right here. The period on tangent is pi. Okay, so what that means is the answers are going to repeat after pi instead of after 2 pi. So all I need to check for is solutions from 0 to pi. So really it's just the top half of the unit circle that I'm looking at because they're going to repeat after that. All right, so from here we're good. So again, I'm looking for anything that will give me 1 over the square root of 3 as I'm going through it. So again, here this, flipping this, y over x makes the 2 cancel, 1 over 3. No square root of 3 is here anywhere. There is here, but when I flip this, that'll be the square root of 3 instead of 1 over the square root of 3. So that's not going to work. Same thing here, square root of 3. That's just 1. And then here is another candidate because when I flip this, the square root of 2 cancels out, and that's negative 1 over square root of 3, which is the other solution that I want. So it's going to be 5 pi over 6. So 5 pi over 6 is the other solution. Now remember, since the period for tangent is pi, the answers are going to repeat after that period. So this is the interval solution. But the interval this time is from 0 to pi. The interval this time is from 0 to pi, right? It's from 0 to pi this time. All right, instead of 0 to 2 pi. It's from 0 to pi. All right. Now we can take this and expand it out to a general solution by taking any of these solutions and adding. Now we're not going to be adding multiples of 2 pi this time. We're going to be adding multiples of pi. Why? Because remember the period for tangent is pi, not 2 pi. Okay, so we have to add multiples of pi, not multiples of 2 pi on this one. And so the other general solution would be 5, oh, this thing keeps breaking on me, 5 pi over 6 plus n pi. All right? And then so that is going to be your general solution. All right, that is your general solution. Okay, so key things to remember with tangent, the period is pi, not 2 pi. So that'll affect the interval that you check for your initial answers, and then also the form of your general solution. So once again, you're not adding 2 pi's, you're just adding pi. All right? Now, we'll come back and take a look at that here in just a moment. We'll come back to this one because there's something I want to kind of show you there. Let's move on to the next one. All right, so in this one, we're solving the equation cotangent of x times cosine squared of x equals to 2 cotangent of x. All right, so once we get down to this one, this is one where we need all the trig functions on one side because we're actually going to have to do some factoring here. So I'll move that 2 cotangent of x over to the other side and we'll get this. We'll get cotangent of x times the cosine squared of x minus 2 cotangent of x equals to 0. All right, so that's my first step. Get all the trig functions onto one side, set it equal to 0. The next thing I'm going to do is factor out a, let me see. Oh, did I write that wrong? That's not cosine. That's cotangent. Let me fix that. Cotangent. Okay. The next thing I'm going to do is factor a cotangent out of these two terms. So I'm going to factor out a cotangent of x. Okay. Factor out a cotangent of x. Now, when I do, that's going to leave me with cosine squared of x minus 2 equals to 0. All right, so I factored cotangent of x out of this. I factored cotangent of x out of this. All right. Okay, so from here, okay, what we can do is, remember your zero product rule allows me to write two equations at this point. If this times this equals 0, then I have two possibilities. Either the cotangent of x is equal to 0, that's one equation, or this part, the cosine squared of x minus 2 is equal to 0. Those are my two possibilities. So let me see if I can solve for both of these. So cotangent of x is equal to 0. All right, so here I'm looking for a value of x, right, or an angle whose cotangent is 0. All right, first of all, let's look at my cotangent. My period is from 0 to pi. That's the first thing. And so when I go in and I look at this now, then cotangent of x is equal to 0. Remember, cotangent is the reciprocal, right, for tangent. So it's going to be, instead of y over x, it's going to be x over y. It's going to be x over y. So really, for x over y to be equal to 0, I need the x coordinate to be 0. So let's see what we can find where my x coordinate is going to be 0 here. And that will happen at pi over 2. So the solution for this equation is x is equal to pi over 2. All right. Now, what about the other equation? Let's see what we can do here. I'll move this over to the other side. And then I'll have cosine squared of x is equal to 2. And then I'm ready to take the square root of both sides, which will give me the cosine of x is equal to plus or minus the square root of 2. And so from here, let's double check the range. So what's the range for cosine? The range for cosine is between 0 and between -1 and 1. All right, so again, the range for cosine is between -1 and 1. And so since that's the case, the square root of 2 is 1.4 something, right? So notice that the positive and the negative, so positive 1.41 and negative 1.41, are both outside of the range, which now we can utilize what I've been telling you to check every time, And we know that this equation has no solution. Why is there no solution? Because, all right, why does it have no solution? Because of the fact that there is nothing that you can plug in. There's no angle to plug in here that would give you plus or minus square root of 2. All right, so there's no solution. It's this value is outside of the range of the cosine function. All right, no solution. So the only solution that we have to deal with for this equation is this one. All right, so my x is equal to pi over 2, and that's the interval solution from, the interval solution from 0 to pi. That's the interval solution from 0 to pi. If I wanted to put it in a general form, that would be pi over 2, right? Plus, and remember this is the cotangent that we're dealing with, and so cotangent has a period of pi, right? It's got a period of pi. And so, again, that's going to be plus pi n, right? So remember, you're always considering the period when you're writing out this general solution. All right, you're writing out that general solution. Make sure that you always take into consideration what the period now here is going to be. All right, and so let's see here. Also, another thing to consider here is that when you guys are looking at this, you might be asking yourself, well, why did I do an open parentheses here instead of a bracket like I had been doing to encompass the whole period? Because remember, at 0 and pi at the end of the period, the values repeat, so you don't have to include the ending one, but you should include the beginning one, right? Well, how come I didn't do it here? Well, here's the reason. Notice that there is a restriction on the domain here for cotangent. The x, the domain, can't be any multiples of pi, right? And so 0 is a multiple of pi. It's 0 pi. And if you notice with cotangent, remember what we said? Cotangent is x over y. And if we included 0 there, that would be 1 over 0. And we know division by 0 is undefined. And so that's a quick explanation of why this is a parentheses instead of a bracket, because we can't include the value of 0 because of the restriction on the domain. So there's really a lot to take into consideration here with regard to the period, the domain, and the range of each one of these functions, because they're all different. When you go through and look at these, as far as notation, what the solutions can be, what's the general form of the solution, all that kind of stuff has to be taken into account when you're solving these equations. All right, so that's probably a good question you may have been wondering about when I wrote that. Okay, all right. Now, there's one more example we want to go through here, and then I'm going to kind of say something about your quiz. So here's the next one. We want to find all the solutions to this equation. Okay, now, here's the first thing that I'm going to do. Notice this is a trinomial now. So what we're going to do is we're going to take the trinomial and we're going to factor it into a product of two binomials. All right? We're going to factor it into a product of two binomials. Okay? All right, so that's the first thing that we're going to do. Okay? All right, so now, remember, these two values multiplied together should give me the first term. So the only way that I can get 2 sine squared of x is to multiply 2 sine of x times sine of x. All right? So that's what my first two blanks should be. All right, now, to finish it up, okay, I need two numbers that multiply together to give me -1. So I know it's got to be a positive and a negative, but at the same time, the middle term is negative sine of x. So I want the bigger one to be negative, which means I want my plus 1 to go here, and I want my minus 1 to go here. All right, so plus 1 goes here, minus 1 goes here. All right. Make this a little more compact here. Equals to 0. All right. And if you wanted to double check it, whoops, I didn't. That should be a minus. If you wanted to double check it, then positive 1 times negative 1 is negative 1. This is sine of x minus 2 sine of x, which is negative sine of x. So we have factored it correctly. Once again, now from here we're at our zero product rule again. So I need 2 sine of x plus 1 to be equal to 0. And I also need sine of x minus 1 to be equal to 0. And we'll solve each one of these independently now. I will move the 1 over and get negative 1 and divide it by 2 at the same time to make sine of x equal to negative 1/2. All right, so if my sine of x is equal to negative 1/2, then I'm looking for angles whose sine would be negative 1/2. Again, let's take into consideration now our domain and make sure we are within negative 1 to 1, which we are, so we're good there. So now I'm looking for angles where the y-coordinate is negative 1/2, because sine of x is equal to y on the unit circle. So let's see if we can find those. Negative 1/2 on the y-coordinate, that's what I'm looking for. No negative 1/2 on the y-coordinate there, but I do see one here at 7 pi over 6. That's one solution. 7 pi over 6. And there is going to be another solution at 11 pi over 6. 11 pi over 6. All right. (11 pi over 6). All right, so there you go. Two solutions there. And let's go now and solve the other one. So I'll move the 1 over to the other side. So we've got sine of x is equal to 1. And so from here, I'm looking for solutions where the sine of x is equal to 1, meaning that I'm looking for the y-coordinate to be equal to 1. And of course, that's over the period of 2 pi. So let's see if I can get a 1. There's 1 at pi over 2. All right, pi over 2. And that one happens to be the only one where the y value is 1 because it's negative 1 there. All right, so we can put all three of those solutions together now to get x equals 7 pi over 6, 11 pi over 6, and pi over 2. All right. And of course, that's my interval solution over 0 to 2 pi. All right. And if I wanted to write this in a general format, it would be 7 pi over 6 plus, remember, the period is 2 pi, so that would be plus 2n pi, 11 pi over 6 plus 2n pi, and pi over 2 plus 2n pi. All right? And that is the general solution. All right, general solution. Okay? All right, so like I say, when you're solving these equations, there's a lot to make sure that you take into consideration. And there's one more thing that I do want to make sure that I point out to you, and that would be this. All right, so On the quiz, it says find all solutions of the equation in the interval from 0 to 2 pi. Now that matches, oh, you can't see that. So find all the solutions in the equation over the interval from 0 to 2 pi. Now, that matches the equation, or excuse me, that matches the period for all of these, even the cosecant. Yep, even the cosecant ones. So that matches the period. That interval matches the period for everything on here except like tangent and if there was a cotangent. Because remember, the period for tangent is going to be pi. But this says find all the solutions in the interval from 0 to 2 pi. Okay, so like I had mentioned earlier in the lesson, once you get down to number 1 and number 4, okay, what you're going to have to do is you're going to have to check the solutions all the way up to 2 pi. Meaning, if you get the solutions from 0 to pi, then you're going to have to add another pi to each one of those to get the other solution up to 2 pi. So in other words, like if you've got one solution in the interval from 0 to pi, you're going to have 2 in the interval from 0 to 2 pi. If you have 2 in the interval from 0 to pi, you're going to have 4 in the interval from 0 to 2 pi. And that's what I was saying here. These are the solutions from 0 to pi, but if it had said write all the solutions from 0 to 2 pi, I would have to take and add pi to this one and add pi to this one to get the other 2 solutions. So that's what you're going to have to check for when you go and do number 1 and number 4 on your quiz, because the interval that the directions ask you for do not match the period for the tangent function in number 1 and number 4. So just keep that in mind when you're going to find the solutions, that you do have to add another pi to whatever you get in order to encompass the interval from 0 to 2 pi. Okay, so keep that in mind for number 1 and number 4. So other than that, that's it. And you're ready for your quiz.